welcome to Bridges Math Week 8, Lesson 1, Unit 2, Module 4. Hi everybody, welcome to Bridges Math Week 8, Lesson 1, Unit 2, Module 4. So now let's think about something. Take a look at the picture below. Think about what you see. This is Charlie's collection of butterflies. Does he have an odd or an even number of butterflies? Think about those two words, odd and even. Where have you heard them? Where have you seen them? Do you know what they are? And if so, does Charlie have odd or even number of butterflies? How do you know if he has an odd or even number of butterflies? Could you tell a friend? Could you tell an adult? Could you even tell your teacher? How many butterflies would he have if he collected 2 more? I want you to think about writing an equation to solve that problem. Go ahead. Get on it. Get that paper, get that pencil out. How can you write an equation to solve the question if he had these butterflies and he collected 2 more? What would you do? Oh, I see those pencils moving. I know you're doing it. I know you're coming close. Keep working. So let's take a look here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 butterflies, and we said we wanted to collect 2 more, so I could add an additional 2. So let's count on from 11. 2 more times. So here's 11. 1 more time would be 12. Another time would be 13. So 11 plus 2 would equal 13. With that number, would he have an odd or even number of butterflies now that he's collected 2 more? Nice work thinking about it, guys. So let's look at another problem here that we have for evens. If a number is even, you can always make 2 even teams. So here we have some penguins, and they want to play a game of basketball. And basketball has 2 teams, and each team has 5 players on it. So we want to see if these penguins can make even teams. So here would be team 1 on this side, and here would be team 2 on the other side. Okay? So let's take a look and see how we can make this into even teams. Okay? So I'm going to take one of my penguins and I'm going to put them on team 1. So there's 1. Now right now this is odd because I have 1 here and I have none here. So this would not make sense. It wouldn't make it even. Maybe think of it like a weighing scale. This scale would be down a little bit because this is heavier because there's a penguin, and this would be up a little bit because it's lighter because there's no one there. So to make it even, I'm going to have to put a red penguin over on this side. Now they're even. One blue, one red. So we're going to continue this pattern. So now I have 2 blue penguins on their team 1 and 1 red on team 2. So this is not even. But I'm going to even it out by putting another penguin there. So now I have 2 on team 1 and 2 on team 2. 3 on team 1 but 2 on team 2, so this is uneven. So now I'm going to go ahead and I'm going to put a penguin there. So now I have 3 on team 1 and 3 on team 2, which is even. I'm going to pause here and let's take a look at how many we have total. We have 1, 2, 3 blue penguins, 1, 2, 3 red penguins. So 3 plus 3 gives us 6. Exactly right. So 6 is an even number. So let's look here. We're going to put penguin here on team 2. Now I have 4 and I have 3. And that is not even. So I want to go ahead and take another red penguin, put it over here on team 2. Now I have 4 blue penguins and 4 red penguins, making it even. And notice if we count how many all together, that number should be even. 1, 2, 3, 4, 5, 6, 7, 8. So we know that 8 is an even number. I'm going to take my last blue penguin, put him here. I have 5 on the one team and 4 on team 2. That is uneven. So I'm going to put my last penguin over here, which again makes it even. 5 on this team and 5 on this team. So now we know that when we are trying to break into equal or even teams, that number has to be an even number. Here's another way that we can make even numbers, something that you guys have worked on when adding your numbers. Doubles facts. We all know our doubles. So let's look. Our doubles facts make even numbers. So here's our doubles. 1 and 1, 1 plus 1 equals 2. 2 plus 2 is a doubles fact that makes 4. 3 plus 3 is a doubles fact that makes 6. 4 plus 4 is a double fact that makes 8. And 5 plus 5 is a doubles fact that makes 10. So again, I want us to look at the pattern that we see with the numbers. So we see 2 coming 1 from 1. We see 4 coming from 2 from 2. We see 6 coming from 3 and 3. We see 8 coming from 4 and 4. And we see 0 or 10 coming from 5 and 5. So in your head, you can think about if we continue to count these doubles, let's say 6 and 6. What will that give us? 12. And again, 1 and a 2 would make a 12, and we'd be back to our pattern of 2, 4, 6, 8, 0. So let's look at odd numbers in making teams. So we have to understand that if a number is odd, you will not be able to make even teams. So we're going to take the same model that we had from our even numbers, where we have our friends penguins that want to play basketball, and they want to break into 2 teams. So we have a total penguins here, and this time we have 9 penguins. Okay, so let's see if they can break into 2 teams. So again, a team of basketball players has 5 on a team. So 1 penguin on one side, 0 penguins on the others. That's not equal. But we can put a red penguin there, which makes it equal. So now we have a total of 1 penguin, 2 penguins. And the number 2 is an even number. But we're looking for odd numbers. So remember, an odd number comes before that even number. Okay? So an odd number here is 1, 2 blue penguins and 1 red. 2 plus 1 equals 3. So 3 is an odd number. So this does not make even teams. But if I put my penguin over here, the total now is 1, 2, 3, 4. And we know 4 is an even number, so it does make equal teams. But again, we're looking at odd numbers, so we're seeing how they don't make even teams. So we're going to put our blue penguin here. We now have 3 blue penguins and 2 red penguins. Notice they are not equal, so we can't have even teams, and the total amount is 1, 2, 3, 4, 5, which is an odd number. I'll even it up by putting my other red penguin here. We now have a total of 6, 3 on one side, 3 on the other. 6 is an even number, so we know that we have equal teams. We'll put our blue penguin down here, and now we'll look at our teams. 1, 2, 3, 4 blue penguins, 1, 2, 3 red penguins. If we count them all together, that is a total of 7. And if you notice, the teams are not equal. So that means we have an odd number and the teams cannot be equal. I'm going to put my last red penguin over here, making 4 on team 2 and 4 on team 1, making a total of 8 penguins. And if you notice, they are equal. So we know the number 8 is even, meaning equal teams. But now we have this one penguin left. So he's got to join his team over here. So now we have a total of 5 members on team 1 ready to play and 4 members on team 2. Well, they can't play because we don't have enough players to fill in. So we do not have even teams. We have an odd number of players, which is number 9, because we have a total of 9 penguins who are playing basketball. So we will not be able to make 2 equal, even teams because 9 total players is an odd number.
Wow, Mr. G, that was pretty interesting how you showed us how we could use double facts to show equal teams and how that makes even numbers. And if you can't use a double fact, then that meant that our number was odd. There was another thing I was thinking about. We can also show even and odd numbers by making partners, because sometimes in school or when I'm at home with my brothers and sisters, we like to play games where we have to play with a partner. And if everybody has a partner, that means that the number is even. But sometimes we can't split groups up into partners with everyone having a partner. Let's take a look at some of those. So for the number 8 with my red counters, I put groups of 2 together. And then we can skip count by 2s like Mr. G was explaining. 2, 4, 6, 8. So we could take 8 counters and put them together in partners, and everyone has a partner. But let's see what happens when we have 5 people. Can we put 5 people into pairs and have everyone have a partner? Let's see. I could put 2 together, 4 together, and uh-oh, we have a problem. There is not a partner for the number 5. So that shows me that 5 is an odd number.
All right, so now let's look at the hundreds chart and how we can use this to identify even and odd numbers and see if we can find a pattern with them. So count these even numbers with me. You see a 2. We skip the 3 and go to a 4. Skip the 5 and go to a 6. Did you just say skip counting? You're exactly right, we're skip counting. Skip from 6 to 8, and then from 8 to 10. Keep going with me. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Have you noticed a pattern yet? You have? All right, well, let's see if it's right. If you said that all the numbers going down end with the ones digit being a 2, you are correct. All the even numbers from 2 on forever, when they end in a 2, are an even. Did you also say that if they end in a 4, they're even too? Man, you're smart. You're correct. All the numbers that end with a 4 in the ones place are even. That goes for the 6s. If a number ends in a 6 in the ones place, it's even. That's same true for the 8s and the 0s. If they end in a 2, a 4, a 6, 8, or a 0, then your number is even. Well, what about those numbers that aren't colored in? Well, let's take a look. Those numbers we call odd numbers, and those skip count also, but they skip over the even numbers. So say it with me. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. So our odd numbers end with in the ones place, the ones digit, the threes digit, the fives digit, the sevens digit, and the nines digit. So if any number ends in any of those red number digits, they are odd. So let's see if we can continue this pattern. That's right. All the numbers in this column here that end with 1 are odd. All the numbers in this column that end with 3 are odd. All the numbers that end with 5 in this column are odd. All the numbers that end with 7 in this column are odd. And all the numbers in this column that end in 9 are odd. And that is how you use our hundreds chart to figure out the patterns of evens, 2, 4, 6, 8, 10, and odds, 1, 3, 5, 7, 9, to help you skip count. All right, so let's apply this to a real world model. So let's say your teacher in class is lining you and some other friends up to go to see the eye doctor down in the nurse's office. They want to check your eyes and make sure that you're seeing okay. So your teacher lines up our first friend here, and we want to know how many eyes he has that's going to be checked out. So we notice that on this person, he has 2 eyes. Well, he's the only person in this line, so it's going to be 2 eyes plus 0 eyes equals, that's right, 2. Now that person stays in line, and another friend comes on in. And your teacher lines both of these students up here. And we see that there are 2 eyes from the first person and 2 eyes from the second person. So what are we going to do? We're going to add 2 eyes from the first person and 2 eyes from the second person, and now we have a total number of 4 eyes. Hint, hint, start looking at the pattern. So we have our first friend, we have our second friend, and now your teacher adds their third friend. So now that we have 3 friends here, we have to add another 2 to this group. So now we have 2 eyes from the first friend, 2 eyes from the second friend, and 2 eyes from the third friend, equaling 6 total eyes. So your teacher now takes the first 3 kids that they've lined up, and we add another friend. And now that we notice we've added another friend, we've added another set of 2 eyes. So now we have a total of 2 eyes plus 2 eyes plus 2 eyes plus 2 eyes. Whew, that's a lot of talking for me. I gotta take a breath. Again, look at the pattern. So now we're getting close to the end here. Your teacher has 4 friends lined up, and now we're going to add a 5th friend to the line. So we're going to see what that's going to give us. We have a group of friends that have 2 eyes plus 2 eyes plus 2 more eyes plus 2 more eyes, and finally 2 more eyes, and that gives us 10. Now our last person we're going to add to the line, your teacher here has your first 5 friends, and we're going to go ahead and add 1 more friend to that line. So how many eyes do we have? Yep, we added another 2. So 2 plus 2 plus 2 plus 2 plus 2 plus 2 gives us 12. Notice the pattern that you see off to the side with the colored numbers. Let's take a look. What do you notice about the number of eyes in each row? That's right. In each row, every time there's a new person added, we have 2 eyes. So in each row, we're adding 2 eyes every time we get a new person. What happens to the total number of eyes every time a new person is added? So we're adding 2 to each time. So we're getting greater by 2 each time we're adding those eyes. So here's a question for you. How many eyes would there be if 8 students were in class? So right now, we have 6 students in class that are lined up. What would happen if we added 8 students in class to line up? Something interesting to think about. Think about how you can use the pattern that you see on this page to answer that question. And then with somebody at your house or on a piece of paper or next to you, describe the pattern that you see. Describe other patterns that you see. And be willing to talk about that with someone next to you or write it down on your piece of paper. Hi everybody, welcome to Bridges Math Week 8, Lesson 1, Unit 2, Module 4.
Thanks, Mr. G. That was a really good example to show how easy it is to skip count by groups of 2 in order to find the total. Now, let's see if the first graders can try it on their own. Look in your packet. Complete these problems. How many eyes are there on 8 robots? I can see from the picture that one robot has 2 eyes. So write an addition equation with groups of 2 to show how to find the answer and write it in the box. Then, see if you can figure out how many feet are on 6 penguins. Write your equation in the box. And finally, how many ears are on 4 dogs? Don't forget to write your equation in the box. Now try a few more examples. First, you'll solve the following equations: 6 plus 2, 10 plus 2, and 16 plus 2. Then you'll figure out if the sum is odd or even. You might have noticed that we're adding 2 to even numbers. 6 is even, 10 is even, and 16 is even. What do you notice about the sums when you add 2 to an even number? Why do you think that is? Then you'll take a look at some subtraction problems. You'll do 8 minus 2, 12 minus 2, and 20 minus 2. Figure out the difference and then decide if the difference is odd or even. Again, you might have noticed that 8, 12, and 20 are even numbers. What do you notice about the differences when you subtract 2 from an even number? Why do you think that is? Now it's time for first graders to show what you know. Mr. G and I showed you a lot of examples about how you can figure out if a number is even or odd, and how you can use even and odd patterns to help you skip count efficiently. Look in your packet. You'll find a hundreds chart to help you work on the patterns and problems with 2 work sample. This will be in your packet, or you can also check in with your teacher on Schoology for your digital lesson.